Okay, so let's do the last example here. Same data path and control, and I'm going to give you some control signals here. Okay, so we are going to say that register write is 1, and this ALU source is 0. So just with this, you should already know that this is a register type. If we are writing in registers, as I said before, the only instructions that write in registers are either the load or a register type instruction. But in this case, we are operating with the 2 registers. So if we are operating with the 2 registers, that means that this is a register type. We are going to do some operation with these 2 registers, and we'll write the result in registers. So the rest of the values here are these, and me give them to you. Of course, if we do an operation with registers, we get the result here, and that is what we're going to be sending out to registers. So this should be a 0. Okay, once the data out of the ALU gets to this multiplexer here, to this one, we are writing this coming here, and we have to write it in RD, which is the last register. So that means that this control signal is going to be a 1. That is the register destination signal. It is not a jump, and it is not a branch. We don't read memory, and we don't write memory. Oh wait, that one is right, but the right memory is here. Okay. The ALU operation is that ALU operation that we said we only have to check the function code to know what to do. So this is basically a 1, 0. That's the code that tells you, look at the function code to figure out what to do. And I think we are done with this, right? We figure out all the control signals. Okay, so what will happen if I mess this up? What will happen if I say that we are going to write in memory? So let me change here. I'm going to mess this up and say that we write in memory. So if you want to take a second to think about it, stop the video now and check it out in a minute. Okay, so this is the memory write signal. We've changed it, and now we have a 1 here, so we are writing in memory. The address that we have here is actually the calculation of the addition of these 2 registers, or I mean the addition or whatever instruction we're doing, right? I don't know, we could be doing addition or subtraction, we could be doing an AND or. Some of these instructions are going to work with the content of these 2 registers and put some result here. But in this case, we are also using this result as the address where we are going to be writing in registers. So first of all, we don't know. We are writing in some memory position, God knows where, somewhere here. And what we are going to be writing is actually whatever we read out of the second register. So the content of the second register is going to be written somewhere here in memory, and we don't know where. Okay, so we are messing up some position in memory, and nothing else happens. I mean, what happens is the rest of the instruction as if it was a register type. So whatever is in here is also going to be sent down to the multiplexer and 2 registers, just with as it will behave with a normal register type instruction. So basically, this is what we are doing here. We messed up the content of one memory position. Besides doing our register type instruction, we messed up some content in memory. Okay, so that's it. I think we're done with the examples. We're done, and that's the last one of the videos for today.